This is the solution to number 9 from the integration review. And it's asking for the integral of sine squared, which is a pretty tricky integration problem because it does just use u substitution. But before you can use u substitution, you need to make a change using a trigonometric identity. And we'll be doing these a lot later on in the class. But this one was apparently in chapter 5 of the book, so I put it on here. So the trig identity that's important here is this guy. that is not what I meant to do. Why is that a star? I have no idea. I'll just, okay. Good thing it's a weekend. It's this guy. And so what this means is that this is the cosine of a double angle formula. And what this means is that I can change sine squared to be something that doesn't have any powers in it. And that makes it into a simple substitution problem. So to make it as easy as possible, well, first of all, we always want to write this the other way around. I wrote it this way because this might be the way you remember cosine of a double angle. But if I rewrite this in terms of sine squared, in other words, just take this equation and solve for sine squared. So basically you're switching the roles of these two and then dividing both sides by 2. So sine squared t is 1/2 1 minus cosine t. So this has nothing to do with integration. This is strictly a trigonometric identity. In your notebooks, it's probably good to have a page or a box somewhere that you're going to collect some trig identities because they will come up in chapter 7. Anyway, then to make the problem as easy as possible, it makes sense that we would use a version of this that matches our problem as much as possible. And we have a 4 theta inside the sine squared here. And so since it doesn't matter what this is, let's just write down a version of this that says sine squared 4 theta. In other words, let's just plug 4 theta in for t here. And in this bit, if the t is equal to 4 theta, then 2t will be 8 theta. So it's a little bit crazy, but this is a true statement about angles and trig. And so that means that we can turn this problem. And again, I haven't done substitution yet. I haven't really done anything other than just rewriting the integrand. But I think you'll see that it makes it a lot more tractable as a problem. Because if this were the problem, the only place that the variable exists, the only place that theta is present is inside the cosine. So it's cosine 8 theta. So this is much more of a straightforward u equals 8 theta. And so that means du is 8 times d theta. And so it seemed like the consensus in class was that people liked messing with the integrands more than they like fiddling with the equations, so I'll go with that. What we talked about was that, so this part is taken care of. The 8 theta just becomes u because of the substitution. And we do the rule of wishful thinking. We see that there's just a d theta here, and we say, oh, damn it, I wish it was 8 times d theta. And so just make it 8 times d theta. Totally legitimate as long as you also remember to add a factor of 1/8. So now that's the same thing. Oops, I didn't mean, oh, yeah, it's fine. And so I meant to do this step at the same time. So 8 times d theta is just du, right? That's what this part tells us. And so let me clean it up a little bit. I have a 1/8 and a 1/2 sitting there. So I'll say 1/16 integral of 1 minus cosine u du. And now it looks not bad at all. You'll notice that I also lost my limits of integration some point along the way. Those were originally in terms of theta, right? The original question was about thetas. And my integral down here is in terms of u. So what I really should do is change my my thetas into u's, and I know how to do that because I know the substitution. I know that u is 8 theta. So for the bottom one, theta being negative pi over 4, well, if theta is negative pi over 4, then u is 8 times negative pi over 4. So that's negative 2 pi. And similarly, if theta is pi over 4, then u is 8 times pi over 4, which is 2 pi. So now that integral is entirely in terms of u. So those are u values now. So fundamental theorem of calculus says the antiderivative of 1 is u, antiderivative of cosine is sine, and I need to evaluate that between minus 2 pi and 2 pi. Well, I do have a 1/16 still, sorry. So I have 1/16 2 pi minus sine of 2 pi is 0, minus negative 2 pi minus, well, sine of negative 2 pi is 0. So altogether I have 1/16 times 4 pi, which is pi over 4. And that'll be my answer.